In this video, I will discuss a JEE Advanced PYQ from the topic thermal physics. First, I'll discuss some basics. Specific heat of a gas under constant volume. The symbol is CV. This is the amount of heat required to raise temperature of 1 mole of a gas by a temperature of 1 degree Celsius. So to do that, we have to supply a heat, and this amount of heat is by definition CV. This we can also get from first law of thermodynamics, which is Q equal to increase in the internal energy delta U plus work done P delta V. This is a constant volume process, so work done is 0 and delta U is N CV delta T. So for this thing, if I put the number of moles as 1 and the temperature rise as 1, so let Q equal to CV. So the amount of heat required to raise the temperature of 1 mole of a given gas by a temperature of 1 degree Celsius is CV, specific heat of the gas under constant volume. So if you take a second gas, one mole of say gas 2, same 1 mole, and increase the temperature by 1 degree Celsius. The amount of heat required for this thing will be different from this one because the gas is different. Let me call it Q2, and that is CV2. This is the first gas, so we can call it 1. Okay. Now what I'll do is I'll make a mixture of these two gases, and it's not an equal mixture. I can make a mixture in any way I like. So I'll take N1 moles of gas 1 and N2 moles of gas 2 and mix them up properly into a homogeneous mixture. Now if we take 1 mole of this mixture, what will be the specific heat under constant volume of this mixture? Can I relate this thing CV of the mixture to C1 and C2 or CV1 and CV2? So this 1 mole will have part of it from gas 1, part of this 1 mole. We can think this is made of gas 1 and this fraction is made of gas 2. So this CV mixture will be a combination of CV1 and CV2, and the weightage of the combination is a mole fraction. So the weightage of CV1 will be N1 by N1 plus N2. N1 is number of moles of gas 1, N2 is number of moles of gas 2, and the number of moles of the mixture is N1 plus N2. And weightage of CV2 will be N2 by N1 plus N2. So if gas 1 and gas 2 are known, then CV1 and CV2 are known. And if I know how the mixture is made, I can find out CV of the mixture. And one more basic concept is first of thermodynamics, which is basically energy conservation. The amount of heat supplied to a gas, a part of it going to increasing the thermal energy of the system plus the work done, which is PdV or P into delta V. And this delta U is N CV delta T, and this Q is N Cp delta T. Cp is the amount of heat required to raise the temperature of 1 mole of a gas by 1 degree Celsius when the pressure is constant. So this is true if pressure is constant. Only for the constant pressure process, the heat supply will be equal to N into Cp into delta T. So with this basic idea, we can solve this JEE advanced question. This is the question. You can read it. A closed container contains a homogeneous mixture of 2 moles of an ideal monatomic gas gamma is 5 by 3 and 1 mole of an ideal diatomic gas gamma 7 by 5. Here gamma is ratio of specific heats at constant pressure which is and constant volume of an ideal gas. The gas mixture does a work of 66 joule when heated at constant pressure. The change in internal energy is dash joules. You can pause and run this question. So this is a mixture of two gases. So CV of the mixture is combination of CV1 of the first gas and CV2, and the weightage is the mole fraction. So N1 by N1 plus N2, and N1 is the number of moles of the gas 1, and this is N2 by N1 plus N2. So 2 moles of gas 1. So 2 by, and the number of moles of gas 2 is 1. And CV is given as R by gamma minus 1. This can be easily derived. So for a monatomic gas, it will be R by gamma is 5 by 3. So 5 by 3 minus 1 is 2 by 3. And second gas, the number of moles is 1. And the total number of moles is 3. And CV2 is R by, for the second gas, gamma is 7 by 5. So 7 by 5 minus 1 is 2 by 5. So this can be simplified. 3 and 3 will go. So 2 and 2 will go. So this is 1 plus 5 by 6 R. So 11 by 6 R is CV of the mixture. So you have to find change in internal energy. So we can use the first law of thermodynamics. Q equal to change in internal energy plus work done. So it's a constant pressure process. So Q can be written as N Cp delta T. And change in internal energy is N Cv delta T. And the work done is being given as 66 joules. Okay, so what you have to find out is the change in internal energy. So I'll get N delta T from this. N Cp minus Cv is R delta T equal to 66. I use the Mayer's relation Cp minus Cv equal to R. So from this I'll get N delta T as 66 by R. You have to find the change in internal energy delta U, which is N CV delta T. N delta T from here has 66 by R, and CV of the mixture is 11 by 6 R. So R will cancel. This will go 11 times. So 121 SI units joules. So the change in internal energy is 121 joules. That's the correct answer. So this is what I've explained here. CV of the mixture is CV1, CV2 combination, and the weightage is the mole fraction N1 by N plus N2, and second weightage is N2 by N1 plus N2. And CV is R by gamma minus 1. This is a basic relation. So for first one, gamma is 5 by 3, so gamma minus 1 is 2 by 3. And the second gas, gamma is 7 by 5, so 7 by 5 minus 1 is 2 by 5. So putting that value, we'll get CV of the mixture as 11 by 6 R. And first law of thermodynamics, Q equal to delta U plus work done, energy conservation, applied to thermal system. Q for a constant pressure process in mixture, Cp delta T. This is a constant pressure process. It's given in the question. And change in energy is always NCV delta T. This is for a mixture. And the work done is 66 joules. It's given in the question. So this, if I take it to the left side, it becomes Cp minus Cv, which is equal to R. It's Mayo's relation. It's a basic formula. So this we get N delta T as 66 by R. So you'll find delta U. Delta U is NCV delta T. N delta T 66 by R. And CV is CV of the mixture 11 by 6 R. So 11 by 6 R, and this by R will cancel. So 11 by 6 and 6 is 121 joules.